Hello my friends, it's Bob. Today we're going to look at the double pole double throw relay in Tinkercad. Here's what the finished project looks like, and you can see it in action towards the end of the video. I don't use a breadboard because the breadboard will hide a lot of the wiring. And with the fact that we can just place these wires out here like this in Tinkercad, there really is no need for a breadboard. If you saw my previous video, it was on the single pole double throw relay. So this will be similar, but the double pole double throw relay is a little bit more complicated. So we will get into the weeds a little bit more than we did with the single pole double throw relay. And be sure to watch until the end because I've got a pop quiz waiting for you to see how well you understand all this stuff. I'll be interested to see how many of you come up with a good answer to the quiz. And just like the last video, I'm going to show you how I build it in Tinkercad. Tinkercad, of course, makes it just a wonderful simulated environment to play around and experiment and see if you got the circuitry right and maybe even pre-build a circuit before you do it in the real world. So that's exactly what we're going to do here. We're going to build it in Tinkercad, but like before, I created an actual schematic, and we'll use that schematic to guide us in building this. I think you'll see that it really helps to have a schematic like this to build your circuits from. And when you get into the more complex stuff, you know, this one is bordering on that. You can actually print this out, have a piece of paper or hard copy of the schematic next to your bench when you're doing this in the real world. And you can draw a red line through every connection that you make so that you know whether or not you've made a particular connection or whether you've connected a particular wire or whatever. It's a really big help. Okay, first of all, I want to show you that the double pole double throw relay in Tinkercad has got a pretty awful diagram on the back of the relay. So I've redrawn it and I've made it look a little bit more conventional, and will probably help a little bit anyway to understand what's going on here. You can see in the Tinkercad one that it's kind of all closed up here. It's really hard to figure out what the heck is going on. So I've opened up those contacts to make it look a little bit more conventional and a little easier to read, I think. So it's a little bit more obvious here that this is the common for one side of the relay, and here is the contact sitting next to the output terminal in a normally closed state. And if you activate the relay by applying a voltage across the relay, and by the way, this is kind of a more international symbol for electronic components. I prefer the squiggly line, but this one's clear enough. So when you apply a voltage to the coil, this contact is magnetically pulled to the normally open output. It's a little bit tougher to see up here, but once you understand what's going on, you can see it, although it's certainly not my preferred graphic element. And then on the other side, remember this is a double pole relay, so we've got this set you could call poles, or really the common is the pole. And you got one pole here, and you got another pole here, so it's a double pole, double throw. Here's the first throw, and here would be the second throw. So when you're on the second pole here, when you activate the relay, this contact is pulled over to this output terminal. I don't know if that makes it easier for you to read or not, but it sure makes it easier for me. Okay, so now that we've gone through that, let's actually do some work here and connect this baby up and see how it works. So here we are with a fresh slate in Tinkercad, and let's go find that relay. First of all, let's change basic to all. You could type in here relay and search for it, but I know it's down here somewhere, so I'm just going to go get it. Here it is. And pull that out. Whoops, before we start, let's take a look at the schematic to help us see our path forward. Here's the schematic I drew. Here's the double pole double throw relay. Again, here would be pole number 1, common number 1, and this would be pole number 2. And then we've got a set of contacts for the first pole, and then we've got a set of contacts for the second pole. It's actually pretty simple to see once you take a look at it. What we've got here is, right here, is a single pole double throw relay. And all we've done is added another one. We put another single pole double throw relay right here. So that gives us a double pole double throw relay. Okay, so there's the relay. And what I've done here is, let's imagine that we've got a situation where we want a fan to blow in one case and we want a motor to run in another case, and we've got two different colored LEDs. So when there is no current running through the relay coil, when we have not applied a voltage to the coil, relay is sitting at normally closed. The contacts are sitting at normally closed. So in, let's call it relay half number 1, the common is connected to 5 volts. So in normally closed situation, we get the 5 volt coming through the common, coming through the normally closed connection, through a relay, through an LED to ground. So because we're going from ground to 5 volts, we've got current through the LED, it will be lit up. The red LED is in the normally open contact. There's no connection there, so it's not lit up. In relay half number 2, I have this half of the relay set to work with 48 volts. Notice the switch is still open, so the coil is not energized, so the relay is still in the normally closed state. So our 48 volts comes down here, goes into the normally closed contact, goes through the motor to ground, so the motor runs. The fan is in the normally open circuit, and there's nothing connected there right now, so it is not running. And what I've done is I've separated this. You can see I've got 5 volts going through the top half of the relay, and I've got 48 volts going through the bottom half. So there's a good example of why a double pole, double throw relay is a good choice, because in this case we've got circuitry that needs 48 volts, the motor and the fan, and we've got circuitry that needs 5 volts, the 2 LEDs. So it's a perfect example of using a double pole, double throw relay. Now, let's throw the switch. Let's say that this is a toggle switch where you can just flip it and then it will stay closed, making an electrical connection here. So 5 volts will go through the coil to ground, so the relay gets energized, and we've got the same 5 volts coming in here through the common. Now that the relay is energized, it's going to magnetically pull this contact up to this terminal. So it will break this connection, the green LED will go out, it will make this connection, so we'll have 5 volts going through this line, through the resistor, through the LED to ground, so the red LED will light up. And then if we look at the other pole, common number 2, we can see that we had the motor running in the normally closed state when the switch was open. Now that the switch is closed, it energizes the coil. It will magnetically move this contact to this output terminal. So now the 48 volts will go through common 2, through the normally open connector, through the fan to ground. So the fan will run, but the motor will stop. So it's actually a pretty simple circuit. It can be a little confusing wiring it up though. So let's go wire this baby up in Tinkercad and see how it looks. And just like in my previous video, what I've done is I've split the screen so we can look at the schematic while we're building over here in Tinkercad. So I've pulled the relay out. What else do we need here? We need a motor, a fan, 2 LEDs, and 2 resistors. All right, so let's start with the switch, and let's switch power to the relay coil. Let's switch 5 volts to the relay coil. And if you know how to build in Tinkercad and don't want to sit through this, you can scroll ahead to the timestamp that I'm putting on the screen now, and you can see the finished product run. All right, we have to be careful with this relay. I spent an hour trying to troubleshoot this relay that was not working for me the other day, and I discovered that there is a flaw in Tinkercad's system. They have got this coil so it has polarity. Most, I think all coils in relays do not have polarity. You just apply a voltage to them and current goes through them. The relay and the magnet, they don't care which polarity is applied to the coil. So long as current goes through it, the magnetic field will be created and the contacts will be pulled by the magnetism. I have never seen a relay coil that was sensitive to polarity, but this one is, so we have to be careful. We have to put the positive terminal on this side. Normally I like to put ground on the bottom of things, but it has to be positive here and then negative at the top. So let's go straight ahead with the positive terminal. Okay, and then negative goes to the top of that coil. All right, let's make sure this works first. And the way that we can make sure it works is that we'll actually show a little animation here of the contacts flipping from normally closed to normally open when the coil has voltage applied to it. So let's run the simulation and let's watch the animation down here as we go. So I'm starting the simulation. We've got a 5-volt power supply, which Tinkercad provides by default, and we can adjust that, which we will over on this power supply. But 5 volts at the switch, but not applied to the coil yet, so the normally closed contacts are still normally closed. I'm going to pull the switch down, and we can see now the contacts went to the normally open terminals. I'll flip that switch a couple times so you can watch the animation down here. So I'm going to turn the switch off. The animation goes one direction, turn it on again, and you can see it flip over as the voltage is applied to the coil. One more time. Off, on, off. Okay, good. So I'm not going to have to battle that bug in Tinkercad's program. I got the polarity right. All right. Now, what we have to do is we've got the 5 volts hooked up to the coil in the relay. Let's start here. Where do we want 5 volts to go? We want to go in the common, in the first common terminal, and it's going to come out the normally closed terminal. So we're going to run 5 volts through the first common. So here's the common right here. So we have to find these terminals. Here's the common one, and there's the normally closed one, and there's the normally open one. And I'm just hovering over these things to get them to light up. So we got to put 5 volts on the first common. So I'm going to get another wire from the 5 volts. I think I'm going to stop the simulation. Get another wire from the 5 volts. And this one we're going to put on the common terminal. And we're going to run that 5 volts through the common to the normally closed out to a resistor. So the normally closed terminal is here. So we're going to run that out to a resistor. And that's, I'm going to put that kind of way out here so we can make it look like the schematic. I don't know if we'll be successful at that or not. So out of the normally closed connection to the resistor. And I'm going to change that wire color to black. Whoops, there was a little glitch there that caused me to have to refresh my screen, but I think we can carry on here with no problem. We left off here with the black to the resistor, and then we want to bring the resistor down to the green LED to ground. Let's make a little bit more room here. Let's get the green LED and rotate that with the R on my keyboard. And then this side goes to ground. So let's see if I can do this and keep it somewhat neat so we can tell the difference between all these wires. And this is going back to the 5 volt ground or negative side. All right, so we've got that little circuit connected. Let's do the same thing with the red LED. That comes from the normally open. That's out here. So let's find the normally open connection and come out here somewhere this direction. And then that goes to the red LED. And let's rotate that. And that goes back to the 5 volt ground. Now, because these are the exact same points, I'm going to connect to this ground right here. That's the exact same point. See, if we just follow the line, it goes to the minus side of the power supply. So instead of getting a whole rat's nest of wires, I'm just going to connect here. All right, we've got that side connected. Let's clean this up just a hair. I'm going to hit the 2 on my keyboard for red. Now let's connect the other half of the switch. Let's go with the normally closed. That's coming from 48 volts. So that's coming from a separate power supply. That'll come from this supply. Let's move this supply down here. Let's go with that. Let's connect the 48 volts to the common terminal of the second half of the relay. So we'll get the positive side out here and try to make some fairly neat adjustments here. And we're going to go to the common. So from the common, it will go to the normally closed connection into the motor. So let's find the normally closed connection and let's come down to this motor. Let's see if we can rotate that motor. There we go. And through the motor to ground, and that's to the 48-volt ground or minus. So I'll come down here and head over to the minus terminal of this power supply. And I'm going to change that black by hitting the 1 on my keyboard. And now we've gone from the normally closed connection through the motor through to ground or to negative. Okay, let's connect the normally open the same way. So we'll come up here and we'll find the normally open, and we're going to go into the other motor. Let me hit my escape key on my keyboard and see if we can rotate this motor. Yes, we can. So let's put this here and move our drawing over a little bit for now. Okay, from the normally open connection to one side of the motor, and we've got a red and a black terminal on the motor which seem to indicate polarity, but a lot of these motors don't care which way you hook them up. You hook them up one way, they'll rotate clockwise. If you reverse the polarity, they'll go counterclockwise. Okay, through the motor to ground. So we'll connect a negative wire here, see if we can make this all work out. And just like the LEDs, I could have connected directly to the other motor, but let's do it this way. All right, we've connected that motor. So we've got all of our LEDs connected. We've got all of our motors connected. Let me start the simulation. And let me see if I can turn this power supply up to 48 volts. I can't. 30 is the max. So we'll just have to imagine that these are 30 volt rather than 48. No problem. And we've got 5 volts on our 5 volt supply, so that's good. So right now, there is no power going to the relay coil. We've got the slide switch in the off position, where I'm sure you're probably aware that between this terminal and this terminal, I'm going to try not to make that thing flash, that's the electrical connection that's being made right now with this switch position up. When we pull the switch down, then the electrical connection will be between this and this terminal. So right now, there is no electrical connection going through the switch. Therefore, no electrical connection going through the relay coil. So it'll be in the normally closed position. Let's see if we got that right. Normally closed, in the first half of the switch will be a green LED, sure enough. And well, we don't know which is which in the motor here, but we do have only one motor running. Let's flip the switch and see if the parts swap. Look at that. Green went out, red lit. This motor stopped. This motor, I don't know if you can see that or not, but this motor is running. And that, my friends, is one way to use a double pole, double throw relay. But wait, I have a pop quiz for you. Before we go, let me ask you this. How would you turn this circuit off? If you wanted to leave your power supplies on, but you wanted to completely turn off the LEDs and the motors, because right now, just flipping the only switch we have in this circuit chooses either or. It does not turn the power off completely. Let me know what you think in the notes below. Okay, that is the end of this exciting tutorial. I'll see you in the next video. And as usual, if you thought this was any good, please give it a thumbs up. And if you'd like to know every time I upload a new video, go ahead and hit that subscribe button.